This is Dr. Fahim Mushtaq. Today we are going to discuss the key expansion function of advanced encryption standard. This is the lecture series of cryptography and network security. As we discussed earlier about the key expansion function, which play a crucial role in generating the round key used in encryption and decryption process. Previously we discussed in every cryptographic algorithm have three main components. First one is encryption, second one is decryption, and third is the key scheduling algorithm or key expansion function or key generation algorithm. Different algorithm carry a different name. So in previous lecture we discussed the encryption decryption process of advanced encryption standard. In today's lecture we are going to discuss the key expansion and its role and its importance. The key expansion takes the original encryption key and drive a series of round key, each of which is used in different round of AES encryption process. Moreover, key expansion function is responsible to ensure that each round of AES encryption algorithm uses a unique key, each derived from original encryption key. This enhances the security of AES algorithm by introducing variability and complexity into the encryption algorithm. It is critical component to contribute to its strength and resistance against the various cryptographic algorithms. This is the basic introduction of key expansion. Now we will move forward how the key expansion function work in the AES algorithm. To create a round key for each round, AES uses key expansion function. If the number of round n into r, the key expansion and routine create n into r plus 1 128-bit key from one single 128-bit key cipher. The first round is used for pre-round transformation where we use the add round key. The first key where we use the remaining key we will use in the round key that is used in the last transformation as the out round key at the end of each round. The key expansion routine create round key word by word, where word is array of four key. Here you can see that the pre-round we use 4 word W0 to W3, whereas the rest for round 1 we use 4 words of W4 to W7. Similarly, in round 2 we use W8 8th word to W11th word. Similarly, up to the number of round. It's depend upon if we use 128-bit round, 128-bit variant key scheduling algorithm or AES algorithm. So we use the 10 number of rounds. If 192, we use the 12 number of rounds. 256 variant if we use, then we are move forward for the 14 number of rounds. In AES 128 variant, where we have used 10 round, there are 44 words. If we move forward, we see the different variant contain different rounds and where we use the different number of words. Because first one is the pre-round where we use 4 word, rest we have 10 rounds in 128-bit variant. It's mean that 10 into 4 we have a 40 and 4 words used in the pre-round, we are total 44 words used in the 128-bit variant of advanced encryption standard. Here let us show the creation of word for AES 128 variant. The process for the other two variant are the same with slightly change. The process is as follows. Here you see that first 4 byte of cipher key is used as a first word, which we said as W0, and used for the first operation using the exclusive OR. Whereas you will see that the next 4 bytes of a cipher key. As we know that we have 16 coordinate in 4 by 4 matrix. First four are first 4 coordinate which contain 4 different bytes, and 4 different which become one word. So the next forward byte become the second word. Third here third word we see that 4 different byte, and K12 to K15 become the fourth word. So we start W0 to W3. That's why we say the fourth word become the W3 value, which use in the exclusive OR operation. Moreover, as we discuss that W0 to W3 we used in the P-round transformation. Now we will move forward and we will see that the process of the round key. The first 4 byte, as we see that in previous slide, W0 to W3 made for the cipher key, made from the cipher key. The cipher key is thought of an array of 16 byte, K0 to 15. The first 4 we use for the transformation, and rest K4 to K7 as previous slide we see that the another process. The next word W4 to W44, which we use in the round transformation. In each round 4 words, and we have a 10 rounds. Then we say that we required the 40 words for the 10 number of rounds. If I mod 4 not equal to 0, then we say that W into J equal to W into I equal to W into I minus 1, exclusive I minus 4. Referring to this figure, this means each word is made from one at the left and one at the top. If I mod 4 equal to 0, then we say that W of I equal to T into I exclusive W into I minus 4. Here T is temporary word, is the result of applying the two routine, substitution word or rotate word on W into I minus 1, and exclusive ORing the result with the round constant R into constant. This is what the process done here. Next we will move forward. We will see that what is the rote word. Rote word is abbreviated as the rotate word. In rotate word routine is similar to the shift RA transformation in the encryption algorithm, but it is applied to only one raw. Routine take a word as array of 4 byte and shift each byte to the left with the wrapping. Similarly, the second one is the subword. Subword is, we say that the substitution word routine is similar to the sub byte transformation, but it is apply only to the 4 byte. The routine take each byte in a word and substitute another byte for it. Third one is here is we use here is the R into cone. R into cone is the round constant, where we see that the R constant is the 4 byte value in which the rightmost 3 byte are always 0. Here you can see that in the example. Now we move forward for the key expansion function or key expansion analysis of key scheduling algorithm. Here is the original design. We see that as previously, this is the complete figure. We have 4 byte of a cipher key, we use it for as a one word. Next 4 bytes used for second word. Next 4 bytes used for third word. Next 4 bytes used for fourth word. And similarly, we have performed the exclusive of operations of each word using this cipher key. Here is the example for the first round and second round and third round and fourth round transformation. Each we will get the different value. Here is the round key function, round key expansion function, and we will see that this one is the original design of key cipher in which the order of transformation in each round is not the same in the cipher and reverse cipher. We briefly discuss here is that first order of sub byte and sub row is changed in the reverse cipher. Second, the order of mixed column and add round key is changed in the reverse cipher. This difference in ordering is needed to make each transformation in the cipher is aligned with its inverse in the reverse cipher. Consequently, the decryption algorithm as a whole is the inverse of encryption algorithm. We have shown only 3 rounds, but the rest is the same. Note that the round key are used in the reverse order. Note that the encryption decryption process is the original design are not similar, because when we have done the reverse order, we see that here is the 10th round, but on the other hand, in the encryption side, we see that we have in the first round we have 4 different operations, which include sub byte, shift row, mix column, add round key. Whereas in the decryption side, we will see that we have the on other side, in the key expansion function, we see that we have only 3 rounds. We have skipped the mixed row operation in the last round. Here are briefly explain the other key expansion variant. In previously we see that the original design of AES 128 variant, but meanwhile if we see that the key expansion algorithm in AES 192 variant or AES 256 variant are very similar to the key expansion algorithm in AES 128. Only have the minor change. What will be the change? Only the words when we use for the encryption decryption process. AES in 192 variant, the word are generated in a group of 6 instead of 4, where we are use W0 to W3 in the pre-round transformation, then W4 to W7 we used for the first round, and similarly we move forward. Here we use 6 word. We can say that W0 to W5 used for pre-round transformation, and similarly on the next rounds. On the other hand, if we see that AES 250 word 6 variant, the word are generated in groups of 8 instead of 4. The cipher key of the first 8 word W0 to W7, instead of we use the 4 words in pre-round transformation. In generally we say that if we use the 128-bit variant, we have 10 number of rounds and we have 44 words. If we see that if AES 192 variant, where we have a 12 number of round and use 52 words. Similarly, AES 256 variant, where we use 14 number of rounds and we have a 60 word combination of 8 words. This is very important in terms of objectives, and in terms of you have an interview, they may ask you a question regarding the number of keywords used for AES 128, 192, 256 variant. Here is the original design of AES as we discussed in previous slides, where we use W0 to W3 word in the P-round transformation, whereas in the first round we use for W4 to W7 in the first round, If we move to the round 9, we see that W36 to 39 using add round key of the round 9. Whereas why we separate the round 10, because here we skip the mixed column operation, and but we have used the W40 to W43 in the word generated from the cipher key words in the add round key. This is actually the original design for the 128-bit AES variant, where we have a 10 number of rounds, and in which we are using the 4 words in each round, combination of 4 words. Similarly, in the decryption side, decryption algorithm, you see that at first round we just take the reverse order of 40 to 43 using the first add round pre-transformation, and we move to the opposite at inversely to the inverse to the round 10. In previous slide we discussed that here the operation are not the similar, the inverse operation are not the similar. If we see that here the round key is pre-round transformation, whereas the round 1 is there. If we see the round 1, if you see the round 1, you can see that the which is sub byte, which is similar to the inverse sub byte operation, and shift raw, which is similar to the inverse shift raw operation. This is what we use in the inverse order in the original ciphertext design. Equivalent pair for the alternative design. For the purpose of equivalence, we see that for those applications that prefer similar algorithm for encryption, decryption, a different inverse cipher was developed. In this variant, the transformation in the reverse cipher are rearranged to make the order of transformation the same in the cipher and reverse order. In here you can see that the sub byte and shift raw pairs. Sub byte change the content of each byte without changing the order of the bytes in the state. Sub raw change the order of the bytes in the state without changing the content of the byte. This implies that we can change the order of these two transformation in the inverse order without affecting the invertibility of the whole algorithm. Similarly, you will see in this slide is the pairs of mix column and add round key. Here, two involved transformation are different nature. However, the pair become inverse of each other if we multiply the key matrix by the inverse of the constant matrix used in the mixed column transformation. This is the cipher and the reverse cipher in the alternative design for the key expansion function. In the alternative design, we see that the gap analysis, what is happening in reverse order. If we see that in the inverse order, the add round key, which is we tied to similar stage of the round 10, then we say that at the inverse we will find the add round key in the inverse order. Instead of using inverse round key transformation in the reverse cipher, the key expansion can be changed to create a different set of round key for the inverse cipher. However, note that the round key in the pre-round operation in the last round should not be changed. The round key for round 1 to 9 need to be multiplied by the constant matrix. The algorithm is left is the see that is the exercise. Thank you for today's lecture. This is the what we are discussing, the key expansion function in this lecture of AES algorithm. We see in detail of AES 128 variant, but on the other hand, we discussed that the key expansion function for the 192 and 256 variant are also the same. Only the difference we have see that the number of rounds and number of words that use in each rounds that generated from the cipher key and used for the add round transformation. And first when we see that the 128 variant, we have see the 4 forward combination of 4 forwards, whereas the 192 variant we have discussed the combination of 6 word, whereas if we use the 256 variant of advanced encryption standard, we are use the 8 variant, 8 pair of combination of the words. Thank you for today lecture, and see you in next lecture. Keep watching our channel. Thank you.